everyone. Welcome to Synersip's webinar. This is Jill Hurston, Marketing Director based in the U.S. Our webinar today on progressive web apps will be recorded. Tomorrow, after the webinar today, we'll process the recording and I will send out an email to everybody with a direct link to the presentation and to the recording. Also, I'd like to remind you that if you have any questions during the webinar, please don't hesitate to start typing them into your chat window and we will get to them as soon as possible. Our moderator today is Mike Watson. He is our VP of Engineering, also based here in the U.S. in Austin, Texas. Mike, are you on yet? I know Mike had to reboot his computer at the last minute, so he might not quite be back yet. But I would like to introduce Nikhil Walvakar. He is our presenter today. He is a senior architect for Synersip based in Pune, India. Nikhil, why don't we just go ahead and get started and Mike will chime in as soon as he gets back.
Hey, Jill, can you hear me?
Oh, hi, Mike. Yes.
Yeah, I'm here. And
okay.
And,
okay, great. So again, I'd like to introduce Mike Watson. He's our VP of Engineering. Go ahead, Mike.
Yes, so thanks, Jill. And welcome everyone to today's webinar. It's on progressive web applications. The goal of this webinar is to help provide a high-level overview of what progressive web apps are, and then ultimately how they fit into the technology landscape. So when and how you would make a decision to use them. I'd like to remind you, as Jill did, that we want this to be an interactive webinar as much as possible. So feel free to ask questions throughout the webinar, and if it makes sense, I'll interject them into the and let Nikhil know. So with that, I'd like to introduce our speaker today. It's Nikhil Walvakar. He's a solution architect here at Synersip. Nikhil, over to you.
Hey. Thanks, Mike and Jill. Hey, good morning, everyone. So, in 2010, The Wired published an article that Web is Dead. The article talks about the increasing usage of apps and how open web is becoming a closed environment. It also attracted a lot of criticism from the community. But it's true that day in, day out, we are connected via apps like alarm, mail, chat, even entertainment apps such as Netflix. Since the launch of App Store in 2008, we continue to see rise in apps. Currently, Google Play hosts around 2.1 million apps, and App Store is hosting around 1.18 million apps, totaling it to around 4 million apps. Now, here is another report about the time spent. As expected, users are spending most of their time in mobile apps as compared to mobile web. The re-engagement features such as push notifications bring back user, and placement on the home screen helps keep user bringing back. But users are spending 80% of their time on their top 3 apps. Not all apps, but top 3 apps. So let's combine these 2 reports. So even though we are spending most of our time in mobile apps, but not all apps are being used. Comscore did another analysis of comparing 1,000 sites versus apps. Here you see that mobile web reach is 2.5 times that of apps. The mobile web sees more unique visitors as it has less frictions to get started. Now if you compare time spent by user, apps have higher number as due to this re-engagement features. The data suggests that mobile web traffic ranges from 50% to as high as 90% of the mobile traffic. You are likely to see similar numbers for your own site or app. So why there is issue with reachability for apps? So let's look at the general installation flow of an app. So we tap on URL or some way of discovery. We land into navigate App Store. We click on install Then a permissions dialog box comes, we think about it, okay, then the app is installed and we use it. So as Gabber of Google has put, in a consumer mobile app, every step you make a user perform before they get value out of your app will cost us 20% of the users. So let's take a look at web apps. So similarly, we tap on the URL and we are directly using the app. So it's a one-click conversion. That's what web apps have, and the reach of URLs.
So Nikhil, can I ask you a quick question?
Yes.
So
Sure.
what you're trying to present there is that while web apps are used more frequently, the native apps, because of their deeper, richer experience, people use them much more often. So once they get onto a native app, they tend to use it longer. Is that what the point of this is? and then what I'm seeing here is that there's also you lose people going through this multi-step process, and that's why potentially web apps have higher uptake. Okay, I just want to make sure I understood.
Mm-hmm. Right. So, like as you mentioned, that these re-engagement features, the ownership of that app, so these all make user spend time in the native apps. Whereas in the web apps, it's reachability which makes them feel.
Okay, thank you.
Does that? Yeah. Sure. So let me continue. So the apps are engaging. Various reports shows that users are not downloading new apps. We lose half of the user during onboarding stage. Various factors such as storage space or access permission could be causing it. There is a loss in user first 3 days of install. Similarly, there is loss of users after 90 days of install. So overall, due to inactivity or the less downloads, even though native apps are more engaging, there is a drop-offs which we are seeing. So let's compare features of native apps and web apps side by side. So apps have everything available locally. Web apps have to fetch everything from the server every time. The re-engagement features help bring back users to the app, like push notifications. From user's perspective, if I install anything, it is for me. Whereas in case of web, it's for everyone, right? We go and access it. There is no address bar. That also is one perspective. Whereas if you take it other way around for the web apps, user always gets fresh app from the server. No separate update step is required. User is always one click away from using web app. You don't need a separate app for iPhone, Android, and desktop. And in most of the cases, the discovery happens through search, and web is easy to crawl and index. So for apps, definitely there is a search engine which comes into the picture, but again, it takes you to the app store, and then the installation steps follows. Now, let's take it in a different angle. Capability on the one axis and the reach on other. Native apps can make use of push notifications, background sync, offline support, fast startup, but they have discovery issues or the installation issues. On the other hand, web is safer, respectful of privacy, easy to find, device independent, but lacks engagement. Google data shows that mobile users visit around 100 sites per month, and as we have seen in the previous slide, so currently there is like no new apps being downloaded. So what if there is a void? So there should be something which has high capabilities and high reach. So what if we make a phone that has every app and it just downloads and runs them on the fly? And guess what? We have reinvented web. So why not use reach of URLs and reach engagement features of apps and define new class of applications, which works on any form factor, fits to it, like it can be mobile, tablet, desktop, or TV. works offline, or do background things. App like interactions, shell plus content model, always up to date. No need to download or go to some store to update the app. Prevent snooping. Users should be able to find the app and start using it quickly. Support features such as deep linking, push notifications to bring back the user. Allow users to use the app from place where they find it most useful, like home screen. No friction, zero install, easy to share. So we have progressive web apps. So a new web app development methodology which augments best of both mobile and web experience. As per Alex and Frances, who coined this progressive web apps term, these are just websites which took all the right vitamins. We don't want our users to see this page. Right? So this is the page which is shown by Chrome when there is no internet connection. The only nice thing about this page is that you get to play a free game by clicking on the dinosaur, but it gets boring pretty quickly. Instead, so users don't expect web
Nikhil, I think your audio is cut out, Nikhil.
progressive web apps are installable and live on the user's home screen without the need of App Store. They offer immersive full screen experience with help from web app manifest file and can even re-engage users with the web page notifications. User experiences on the web should feel like an integrated part of the user's device. Instead of having to reach through a browser window, the experience should feel true to how user interacts with the device. So these are some of the characteristics of PWA. So recently mobile traffic has surpassed desktop traffic. It's true that we still have unreliable networks. So those are also called as Li-Fi networks. No need to develop separate iOS, Android or web apps. Browsers now have access to local devices such as camera, microphone, push notifications, geolocation, etc. And major factor, no need to have separate install state. So let's go ahead and check one live app, Washington Post. So with nearly 55% of their traffic coming from mobile devices, the Washington Post knows that providing a great reading experience on mobile devices is critical to their long-term success. So here is the new experience. At first, when we are using, it's like a normal site, except it loads quickly. So as we use multiple times, we can assume that user is interested in the contents and could give a permanent space on the home screen. So browser prompts to add to home screen. So as we tap on it, a feedback is given that, hey, your app is added to the home screen. Go back to home screen. There is the icon, just like any other native app. So when you tap on it, a splash screen starts the app. Once it is fully loaded, you see the web app without address bar. You are in the app world, but at the end, it's still a web app at its core. But for the user, it's like a native app. So let's check what happens if you switch the app to another app. So So as we tap on the switcher, so we see PWA is shown alongside of other native apps. The user can close the app independent of other apps or browser tab. So let's bring back the capability versus reach chart.
So
PWA
Nikhil,
perfectly
Nikhil,
fits.
can I ask
Yes.
a question?
Mhm.
So the fact that the navigation bar had disappeared, or the web sidebar, is because it's now running in the PWA framework versus as a native app, or as a web app, or a web page, I should say. Is that what's going on there, or explain a little bit more about that?
Sure. So, as I mentioned, it's a web app which is running. So there is a browser instance, not a separate instance, but it's like a tab which is running. But only thing is, it's treated as a equivalent to a native app. So in that case, no address bar is shown. So that is all handled through app manifest, which will just get to it. And you can, let's say, see it as a equivalent to full screen mode on a web page. So you just see the app, and there is no bookmarks tab or address bar which is shown.
I see. Thank you. And then follow up to that, can you go directly from the web page to the progressive web app into that mode, or do you have to navigate to the home screen, or were you just showing something like capability there?
Mm-hmm. Yeah. So when you are accessing a progressive web app through a browser, it behaves as a normal web app. Like, it's not running as a separate app altogether. Now, when you add it to home screen and then start it, only then it starts as a separate app. So you had to add it to home screen and then start from that point onwards. So to see it as that.
Yeah, one more question came up from the audience.
Mm-hmm.
Are you able to, is there like a sign-in process, or are you able to store locally information in the progressive web app?
Yes. So progressive web app, like at the end, it's still a web app. So everything what a web app has access to, like local storage, cookies, or index DB. So those are also available to progressive web app. So only thing is, if you are using a session storage, so that is going to be different for browser and that the progressive web app, but everything else should be common. Now, I'll just extend to same. So on the authentication side, so there are some hiccups around when you are using social sign-ins, but the new recent updates to Safari and Chrome, so there are ways you can tackle those issues. Does that answer the question?
Yes, I think so.
Mm-hmm.
Thank you.
Okay. Okay. So this chart about capability and reach. The PWS sits perfectly in the top right quadrant with engaging experience, and it integrates the power of URLs to reach broader audience. So let's see what all we require to be qualified as PWA. The web app should be served securely, should implement a service worker and a manifest file for the app. So HTTPS is a key component to the permissions workflow for both these new features and updated APIs. Many older APIs are also being updated to require permissions to execute, such as geolocations. So what browsers are doing is any sensor or device which a web app wants to access, they are mandating to should be only available if your website is served securely. Now, thanks to Let's Encrypt for enabling users to acquire SSL certificates for free and most user-friendly way. The app manifest. App manifest is just like a JSON file which defines how browsers should behave for add to home and launch from home. So now, as part of this app manifest, you can configure app name, which is also shown when you to the icon which is added to the home screen. A short name, theme colors, icons, starting URL. So these all are configurable in the app manifest. The browser is going to prompt user for installing app, but we can take control of this behavior and prompt user only when a habit loop is built. For example, user completed checkout for e-commerce app, or user is ready to subscribe to some service. So that way, like you don't want to prompt user like in between or something. That might break the flow, because as you add to home screen, then you have to start app from a different place. So it will differ as per user experience. Web App Manifest is supported by Chrome Desktop and Android, and also by iOS Safari. It's still not supported by Firefox, Edge, and Safari, but there are few workarounds around that which can help us. So one thing which I remember is that back in 2007 when iPhone was introduced, Steve Jobs had mentioned about a world where web apps will be used instead of for anything on the mobile. And Safari, iOS Safari, actually has add to home screen even before this PWA was coined. Going ahead to service worker. Traditionally, any web app connects to a web server to fetch its contents. Now, service worker is like a client-side programmable network proxy. So it provides you fine control over requests it handles. So you can control the caching strategy of the data request differently compared to the image request. Service workers are equivalent to scripts, and they run separately from the browser's main thread. So browser's main thread is where all the rendering and all the user interactions happen. So service workers are not blocking that thread, so they run independently. So here's one flow of caching. So every request that is generated by page, that is routed through service worker. And then it gets back to service worker, and then service worker can decide whether to cache this resource or not. Another use of service worker is for the push notifications. Service workers run independent of the web application and can receive messages when not active. That means even if your application is not running, you have closed that tab, or even when the browser is closed, it can receive those notifications, just like a native app. So service workers are now supported by all major browsers. So it's not like a really bleeding edge technology. Now, what about the framework support? So every major framework has support for service worker and in turn PWA. You can get quickly started with help of tooling what they have provided. In case you want to customize and have fine control over service worker or caching strategies, Workbox is the right tool for it. So it allows you to mention different strategies, configure different URLs and their strategies. Here is a list of early adopters, and there are many more who have joined this journey. PWA is now well accepted by the industry. More case studies are available on the URL which is shown on the screen.
So Nikhil, I got a question from the audience. If you, So the question is, why wouldn't you just always use progressive web apps if they behave like native apps? Is there some major limitation?
So I just missed one word, like why don't you always?
Yeah, why wouldn't you always use? I mean, it seems like progressive web apps, are a good solution. Why wouldn't you use it all the time? Is there some limitation that's preventing it from being, more widespread use?
So, though, let's say progressive web apps are giving best of both worlds, native apps still have some, I'll say, edge over it, saying that the immersive experience and the interactions which we have. So that's there. So when we go through the case studies, I'll highlight the case study by Spotify, which had similar concern about whether they should have a native app even if a progressive web app is there. So I'll definitely answer that over there.
And then the point of showing the browser capability, it's not all browsers support all features. Is that right?
Yes. So it's giving idea about, like as you were asking, that are there any limitations? So in web app world, the first limitation starts with the browser support. And traditionally, we have experienced that a lot. Like IE does not support something, or Safari does not support something. Chrome is ahead in the race. They have multiple functions available or multiple APIs available. So that's the case. So for any web app developer or anyone who is building web app, that used to be a major concern about browser support.
Okay, thank you.
So let's talk about Book My Show, India's largest ticketing firm with 50 plus million monthly visitors. Their 84% of transactions happen on mobile, and the company's mobile web traffic recently overtook their desktop web traffic. Even with this growth in traffic, the company still encountered high bounce rates because of their mobile website's load speed and the user experience weren't optimal. The native app posed different problems such as heavy data usage and data storage. If user uninstalled the app, the mobile web did not work the same way. So they set a goal to enable checkout within 30 seconds for their mobile web. Within 10 months of a PWA was built, which is optimized for speed. The new mobile app drove 80% increase in their conversion rates, 54 times smaller than the Android app and 180 times smaller than the iOS app. It takes less than 2.94 seconds to load and enable checkout within 30 seconds. Moving ahead with another study, case study about 5 miles. It's a neighborhood or nearby shopping app. It has around 7 million app downloads and mostly discovered by mobile web. Now, the problem they were facing was like not everyone was downloading the app. So as we have seen, as soon as we hit that download claim, so we see starts in the dropouts. So getting users to get back to the app and complete the flow was costly and challenging. So the new strategy delivered dramatic improvement in overall user experience. They have seen a 50% decrease in bounce rate and subsequent 30% increase in the time spent on the site. Engagement rates are now comparable to the native app. So like to quote their CEO, with the new user growth rate of 100% quarter on quarter, the mobile web is at our heart of our success. It's a major venue for low cost and highly effective customer acquisition and engagement. So as we have seen previously, it's easy to acquire customers, and now with help of PWA, we can continue to have that engagement for our web apps. Spotify. In the year 2017, there was no way to listen Spotify on a mobile web. So native apps was the only option. So that time, mobile web was a kind of placeholder to download the app. millions of potential users were failing to play music because of download friction. The hard download wall was hurting the group. They decided to go data-guided route. Mobile web would unlock the growth. A hypothesis was made. An experiment was conducted. The experiment was to listen to one song on web before you download the app. Spotify saw 54% increase in day one plays and 14% increase in 30-day retention active users, and also 30% reactivations. So the old users which were not using app or website, they were back online. So they had a concern that web experience will hurt app download, but the data indicated that PW users were downloading the apps. So the question which you had about why not go with that route. So like in case of Spotify, the kind of engagement which you get on, let's say, native mobile app, that is different. Or you can have that immersive experience. Building that much app on web, I won't say that it's not possible, but again, there are limitations to it. But in case of Spotify, what they found is PWA and native apps are not competing each other, but they are also complementing each other. So they saw 30% increase in the native app download by PWA users. Okay, I'll continue to the next one. Starbucks. Starbucks released their mobile ordering app nationwide in 2015. When it came time to add ordering functionality to Starbucks website, they wanted to create a system that would be universally accessible to both established and emerging markets. Now, because PWAs are built around concept of offline first, they are great for emerging markets like rural communities where internet connections are less reliable. They are also good for people on the go who may go in and out of internet connectivity throughout the day. Like, let's say you are taking a subway. The goal was to build a Starbucks PWA that will allow customers to browse menu, customize their order, add item to their carts, even if they weren't online. So with the new app, they saw increase in number of customers joining rewards program. Time to interactive is 2 times faster. Users were able to sign in with help of credential management API, and paying is just 2 taps away. So Starbucks has used credential management API, which is a new API which helps user, again, like in a web app, you have to go to a, let's say, login screen to log in. So user enters the username, password, and then you log in. So even that was causing like one sort of friction. So this credential management API helps to solve that. So Starbucks utilized it and they saw phenomenal results with help of that. So till now we have seen all the mobile kind of case studies. Mobile has driven a lot of evolution of progressive web apps, but while the growth of mobile has been so strong, desktop usage is still growing.
Hey Nikhil, can I interrupt
Yes.
for just 1 second? There was a question that just came in that's related to that section, which is the examples you've shown were all consumer type products. Do we have any examples of more of a worker-based app where someone's using it to perform a job function? And is it applicable in that case? So for instance, like an expense management system, or like you're trying to upload your receipts for submitting expenses, those types of applications.
I need to get back to you on that, but we are working on one app. It's not exactly similar to expense management, but it is around exam kind of survey where a user are supposed to fill up, answer questions, and it also records a video. So now what we are utilizing over there is, so once task is done, user is not running the app. All the data which is recorded is being sent as a background scene to the server. Again, due to this intermittent network connectivity, that's where being used. So in case of, let's say, task management app, as we take example, so we can do the same. So that's definitely possible. It's not just for consumer apps.
Okay, good. Thank you.
Mhm. So this is a usage pattern of various devices across time of day. So mobile phone usage peaks in the morning and evening, and the tablet also significantly higher use in the evening. Desktop usage is more evenly distributed throughout the day than mobile usage. It has a significant use during the day when most of the people are at work and their desks. So starting in Chrome 73, progressive web apps are now supported on all desktop platforms, including Chrome OS, Linux, Mac, and Windows. And so even the service workers are supported by other browsers. So on desktop, they run into their own window, not on a different tab. So, so are you running service worker? So probably we are not sure if we are using it. Try this URL, chrome:// service worker internals on your Chrome to see how many service workers are installed. My browser has around 150 plus service workers installed. The PWA is, like as I mentioned earlier, it's now properly accepted by industry. Let's check behind the scene.
Yeah, Nikhil,
So when we
one more question for you. It's sort of, it came from the audience. They were asking if there's a way to enforce that you use only certain browsers for the type of apps. I mean, is that inherent in the framework, or if someone's using the wrong type of browser, are they going to get a bad experience?
So even that is supported right now. Like as I was mentioning, that we as a web developers always fear about the browser compatibility. So there are ways in which you can identify a browser and then do a polyfill, which is like whatever functionality is missing in that browser, you try to emulate that functionality over there. So the mechanism that we use to check browser, which could be something like a user agent checking or some other ways. So that way you can find out which browser it is. And then if you need to do it, show a message or something, that is possible.
So you'd have to write something custom to say, use this type of browser for the best experience, for instance.
Yes, right.
Okay, thank you.
Let's see what happens behind the scenes when we access the web app first time. As part of initial response, service worker is received by browser and registered, and all subsequent requests are routed through the service worker. Any returning user has the service worker already available and has it installed, so they get advantage of caching. But now, what about the first load? Because first impression matters. No one likes to wait. Double-click by user, Google found that 53% of the mobile site visits were abandoned if a page took longer than 3 seconds to load. BBC also did a similar kind of analysis, and they found that they lost an additional 10% of users for every additional second their site took to load. Google built a tool to see how performance could potentially affect your revenue. So this is a kind of simulation, like a site has monthly 5,500K visitors and conversion rate of 2.2%, and average order value is $150. So if we go from 3.1 seconds to 1.4 seconds, so you see that's the revenue improvement that you could get. So that's why the speed matters. So for the first time visit, that's where AMP or accelerated mobile pages comes for the risk. Now, AMP is a separate technology or separate tool in addition to PWA. So we'll get to the differences as we move ahead. So AMP's unique selling point is the almost instant delivery. Like as soon as you tap on something, it's loaded. A characteristic that makes AMP perfect fit for the first user interaction with your mobile app. AMP is based off HTML, CSS, and JavaScript like every other website. The only difference is AMP does not allow custom JavaScript. So we consume the JavaScript which is provided by AMP. So let's check how AMP works. So we have a web app which serves HTML pages and consumed by PC or mobile. The web app also serves app HTML, which is a HTML but with AMP specific tag. These pages are cached by AMP and which are available at edge locations. For any user, it's almost near to where the user is on the network. Now, search engine indexes these pages separately. And when accessed through mobile, these pages are served. Let's take a look at New York Post, which is amplified. Okay. So let me just go back to show. So as you see, these cards which are shown, those are due to the AMP. So a search engine such as Google is able to recognize those. And we see a AMP icon showing that it's an AMP page. Now, as we tap on the page or tap on the card, the site is loaded instantly. So we don't see any lag or any blank screen or even for that matter, any loader. So AMP helped Washington Post as well. So we have seen its use for the PWA. So it increased returning users from mobile search by 23%, with nearly 55% of sorry for that. With nearly 55% of their traffic coming from mobile devices, Washington Post knew that providing a great reading experience on mobile devices is critical to their long-term success. So this is the side-by-side comparison of Washington Post app. Sorry. So the new app loads instantly within 0.9 seconds, whereas old app is taking 3.3 seconds to load. So now let's compare both approaches. So PWA allows much greater interactivity and engagement, but they do not have the instant first load characteristic. Remember, service workers cache the assets on the first load, not for the first load. So AMP is ideal solution for so-called leaf pages, the content pages that your users discover organically through a search engine, shared by a link or a friend, or through another site. Because of AMP's specialized pre-rendering, AMP pages load extremely fast, which in return means much less drop-off. A good strategy is to make entry point into your site through AMP page and then warm up PWA behind the scenes and switch it to it for onward journey. Please note that it's not mandatory to have both AMP and PWA to be used in combination. We can use them independent of each other. So AMP provides the instant first delivery, whereas PWA provides all the caching for the engagement for the returning users. So let's recap the comparison of native apps versus web apps and add PWA to it. So as you see, the PWA and AMP combination meets all the requirements. So it's about the user experience. So the question is where to start. So what if we already have an app? So we can take a bold decision and build everything from the ground up. So this is always the dream of an architect. But it may not be good for the product. So we can build a simple version or take a single feature and give it to customers, get a feedback and proceed. You can take the path which is appropriate to you, your web app and your users. But a data-guided decision is a must. You must analyze the patterns, find out where are the drop-offs and use it. So is PWA is a magic wand? So PWA empowers you with tools to build the app experience for the web app. You need to understand users, their pain points, where are the drop-offs. Excuse me. There are the drop-offs. Analyze user behavior, run tests. You might conduct an A/B test around it, and then find out a path, a critical path which users need, and then work towards it. Here are some guidelines on achieving performance goals. Speed creates perception. Always preload key resources. Don't reload heavy resources again and again. Keep the next page ready. Inline critical CSS for app shell helps for the fast rendering. Split or tree-shake the JS bundles. Use appropriate compressions or formats such as Broadly or WebP for serving your contents. Configure caching properties. Include performance check in the builds. Use re-engagement features, and there are many more to it. So PRPL. So this is a pattern which can be used to optimize your web user experience. So push critical resources for the initial route. So with help of HTTP 2, you can push assets from the server to the client. You can, on the server-side rendering, we can render initial route, or we can pre-cache the next route which user is likely to navigate, and lazy load everything else which you don't need for that initial rendering. Now, how to measure the performance? We can follow rail model to achieve this performance. Complete a transition initiated by user within 100 milliseconds. Users spend the majority of their time waiting for site to respond to their input and not waiting for the site to load. Aim for visual smoothness. Users can notice when a frame breaks are very low. Produce a frame in 10 milliseconds. Maximize idle time to increase the odds that the page responds to user input within 50 milliseconds. Optimize for fast loading performance related to the device, the network capabilities that your users use to access your site. Currently, a good target for first load is to load the page and be interactive in 5 seconds or less on a mid-range mobile device with slow 3G connection. So how we can measure the performance? Chrome Dev Tools. It's a built-in tool into Google Chrome. Provides in-depth analysis on everything that happens while your page loads and runs. So it provides audits, and there is a separate performance monitoring tool which is built in, which can give you information about how much time it's taking to, let's say, waiting for server to respond, how much time it took to download the resource, how much time it took to, let's say, process JavaScript and then execute it. Another tool which is webpagetest.org. So you give webpagetest a URL, it loads the page on a real Moto G4 device with slow 3G connection, and then it provides you with a detailed report on the page load performance. You can also configure it to include a Lighthouse audit report. So Lighthouse is a tool which is available in Chrome DevTools, like in Chrome browser, as a Chrome extension, or as a node module which can be included into our build systems, or within the web page test, the earlier tool which we saw. It simulates a mid-range device with a slow connection and runs series of audits on the page. And it gives report on load performance, as well as it gives us suggestions on how to improve. It also has ability to audit on the accessibility, how to make page easier to maintain, and it also measures your qualification for progressive web app. And there are a few more checks which you can do, similar to search engine optimization. So the performance always matters. So everything revolves around the user. Make sure there are instant feedbacks for each interaction. The app should be interactive under 5 seconds. I would like to end it with quote by Chris Hellman. PWA is try before you buy. Now, who doesn't love to try before buy? So let user visit a web app, try it out, use it, and then as they build habit around it, habit loop, prompt them to add to home screen. So PWA gives you option to try it before you buy. That's it from my side. Any questions, Mike? Over to you.
Yeah, thanks, Nikhil. Very, very good. So we have a few minutes for questions at the end here. So go ahead and start entering your questions in the chat box if you have any additional questions. And while you're doing that, I'm going to talk a little bit about Synerzip. Can you progress to the next slide? So Synerzip is a co-development partner who we focus on helping our customers accelerate their delivery and also identify or fill skill gaps within the organization as they come up. We can do this at a lower cost than an in-house team based on the fact that we source most of those resources out of India. We do have a U.S. presence, but mostly we like to work in a model where the development comes out of that India team, so we get the best savings. Next slide, please. Synerzip's been around for over 14 years. I think we're surpassed 15 years at this point. And we've had a wide variety of clients, some pretty good names here. We like our clients and they like us, so it's a good relationship. Next slide, please. So our next webinar coming up is on Tuesday, July 23rd, so it's in about a month. It's Unleash the Power of User Stories and Agile Product Management. I'm looking forward to that one. Next slide, please. Oh, and by the way, feel free to go online and register for that webinar if you're interested. It's available to register now, or we will be sending emails to remind you later. So with that, there's a few other questions here. We have just a few minutes, 5 minutes, so I'll try to pick a couple interesting ones here. There's a bunch of technical questions, which we'll definitely get back to those folks offline, because I think those are going to be difficult to answer quickly. But there's a couple of questions around. I'm just looking through the questions. Sorry. So it seems to me that so there's this idea of caching, which is really taking the remote data and bringing it closer, but it's not interactive data, right? So it seems to me that there's a inflection point of use for PWAs where if you have a lot of need for local storage, like for instance Spotify has music storage, it doesn't seem like a good application for progressive web apps. What's your thoughts on that?
Yes, so as it's mentioned in the question that local storage has some limitations. So definitely, so that's where probably the combination of a web experience and the native experience comes into the picture. So like the last slide says that you try it before you buy it. So you get user into the your ecosystem through the progressive web app as they get used to it for more immersive user experience. So we can onboard them to the native app and then the experience continues. And so they get like it's a more engaging and then again you get a lot of other facilities such as storage.
Yeah, that sounds like the Starbucks. It's not Starbucks. The Spotify use case.
The Spotify use case, yes.
Which is probably why they went down that path, because you can't really build a robust Spotify-like application in this technology, I'm guessing. So along those same lines, when you're dealing with offline data, it's treated more like a web app at that point, right? Is that how it works, or can you explain that a little better?
I missed again a few words in in the offline.
So if you're dealing with the data, it's treated more like a website if you're interacting with the data frequently, right? There's not like local storage that's managed and then pushed back into the server.
So service worker provides background scene. So as like we were saying, so it intercepts all the requests. So if you are sending some data to the server, you can register for the syncs and then push data accordingly. Like let's say, as we were talking about kind of task management app. So whereas I'm using it offline or I'm, let's say, on a subway on the way to office and I'm just adding the task. Maybe there is no connectivity. It's currently storing into locally, and as soon as the connectivity is available, it can start sending out to the server so that it's stored securely and available for any other device which I have.
Okay, and then one last question, and we have just a minute or so, hopefully it can be relatively brief. Can you just briefly describe the difference between a service worker and like a web API, like how those are different?
Service worker and
a web API. So, like typically in a mobile model, you have, a front-end code that interacts with a back-end API. So how's a service worker different than that? If you can make that a brief answer.
Sure. So service worker is like a proxy. So it's not a web API. So whenever you request something from the network, it will be first intercepted by a service worker and then routed to network, meaning it could be your backend server or let's say API gateway. So every request will just route through service worker. So what it helps is service worker knows which data is being requested from server. So next time, let's say if you are requesting same data, it can just get it from the cache and serve it. Like, let me just show you here. So now in the first request, it goes through service worker, gets the data from the network. It's cached. Okay, and then served, and as soon along with the caching, it is served to the page as well. But let's say if you just clear that out, and if you now request same data again, so service worker knows it's available in the cache. So it will be something similar to page gets it from the cache and then it uses directly. Only thing is it will be routed through service worker.
Yeah, so it's more like a manager. It's more like a manager than a server of data.
Right.
Gotcha.
Yeah, it's just making sure that you're not doing, let's say, requesting same data again and again. So if it's available, it will just provide you that data.
Okay, I think that helps clarify that. Thank you. And with that, we're at the end of the webinar time. We might have gone 1 minute over. I apologize for that. I'd like to thank Nikhil and everyone in the audience for joining us today. If we didn't get to your questions, please feel free to follow up with me or Nikhil directly, and we'd be glad to answer any questions you have or have continued conversation on this. Thanks everyone for attending. Have a great day. Bye.